last proof. We're given that AD is perpendicular to DR. I'm going to right away go ahead and draw in a little square here in the corner. And same with AB and BR. I haven't yet said that those guys are 90 degrees. That's the only thing I can say after saying that something is perpendicular, is that then the angle that's formed is a 90-degree angle. I haven't said it yet, but I just want to be able to visualize it in my diagram right now. And then I'm given that AD is equal to AB. And I want to prove that angle DCR and BCR are equal. Starting from the top down, what I've been given so far is leading me to say that triangle DAR and BAR are equal to each other. I could prove that AR is equal to AR. I notice it's a right triangle with AD as a leg and AR as a hypotenuse, and so I could prove HL between these two triangles. And then, so why is the given leading me towards those two triangles? Because those two triangles being equal is not going to help me with my proof statement. Because my proof statement is DCR and BCR, which means I could either, again, talk about the two big triangles on either side or the two smaller, like sliver triangles at the bottom. I'm probably going to go with the big triangles because I know that AD and AB are equal to each other. I see kind of a similar pattern to what I was doing. What I was doing up above. Yeah. So we're going to do that. Formulated plan. I know I'm going to be proving that DAR and BAR triangles are equal because of hypotenuse leg. I know I'm going to be using CPCTC in some way to then prove that ADC and ABC are equal. And then I'm going to use CPCTC to then say my final angles at the bottom are equal. That's a general plan. I know that my first piece is HL. You could even take note on the side of like what you're going to be doing to the side of the diagram and write out that whole thought process, or like write out ideas that you have and like use them as a thought bubble. You could even like connect some bubbles together of like, okay, well then that could lead to that and that could lead to that. You could always plan this instead of in your head. You could plan it on a piece of paper before you ever write it out. Okay, I know that I've been given that those segments are perpendicular, but I haven't yet said that those angles are 90 degrees. That is the only thing I can say. I cannot yet say that they are equal to each other. I have to first say that they're 90 degrees and then use the fact that they're 90 degrees to say that they're equal to each other. So ADR equals 90 degrees and angle ABR equals 90 degrees. The reason is because that's what it means to be perpendicular. So definition of perpendicular. I hope you guys are still keeping up your reason sheet and using it and have it next to you, right? If you forget what reason it is, or like if you just blank on what to do next in terms of a proof, use your reason sheet as kind of like a way to brainstorm and see the patterns, right? You should have been like drawing pictures next to your reasons of what's going on with them. And so being able to then like look at those pictures and then look at your diagram and say, oh, I've got something like that in my diagram, and this is a pattern that I followed in the past. Now that I've said that those guys are 90 degrees, I can say, well, hey, since this guy equals 90 degrees and since that guy equals 90 degrees, then they must be equal to each other. That is our transitive property of equality, because a whole half of the equation was taken away. I've now proven that those angles are equal. Oh, shoot. Oh, okay. Very common mistake. I want to prove that HL I want to prove HL, which means I don't need to prove that those angles are equal. Instead, what I need to do is I need to prove that those triangles are right triangles. Okay, so very common mistake. I feel like I've warned you about this and I totally just did it. So I'm going to erase this. Instead of saying that those angles are equal, now I'm going to say that those triangles are right triangles. Triangle ADR and triangle ABR are right triangles. That's because of the definition of a right triangle. Okay, so I've said that they're right triangles. I've got a leg equal to a leg. Now I need to say that the hypotenuse is equal to the hypotenuse. So that's AR. That's your reflexive property. Now I've said all I needed to say in order to say that DAR and BAR, that triangles are equal to each other because of HL. And now that I've said that, I want to move on to saying that ADC and ABC, the triangles, are equal to each other. I know I have AD and AB. I could say CA and CA. And then I realized that at angle A, we're sharing angles with the triangles I've just proven to be equal and the triangles that I want to prove to be equal. So I'm going to go up here and label those angles 1 and 2. And say that they are equal to each other. So I could then prove that the triangles are equal. This is because I just proved that two triangles are equal almost always. Immediately after proving two triangles to be equal, you're going to say CPCTC. I need to say that AC equals AC. I'm going to be sneaky here and throw it in here earlier on in my proof. So now I have side angle side between DAC and BAC. Now I can say DCR and BCR are equal to each other. Again, remembering, so instead of saying DCA, they said DCR, and that's totally fine. You don't have to specify that they're the same angle because it's just how you've labeled it. DCR is congruent to BCR. And again, seeing the pattern. Oops, I forgot the angle symbol. All right, that is your proofs the next level notes for today. So your homework is going to be a little bit more challenging of proofs, and that's everything. Good job.